Thanks everybody for coming. I know it's late in the day and the party's tonight. I really appreciate you guys coming. Rich and I certainly appreciate it. We've got a Raspberry Pi up here if you want to take a look at it, and then an application that visualizes, actually supposed to visualize the data off the Raspberry Pi, but we're not getting a signal through this giant Faraday cage that is the building. Anyways, this is visualizing air traffic data with the FAA satellite-based surveillance system and Raspberry Pi. So the goal today here is just very short spiel about what we do. And we're going to talk about innovation and disruption and how IoT is growing very fast. And then we're going to go into a very specific use case around the Raspberry Pi for air traffic control data. But there are many other use cases. This is just a great, inexpensive endpoint, and this solution could be used over and over again for many different types of use cases. We'll go through all the components that I assembled. This is a little bit more refined. There's a nice case that comes with this one. But you'll see originally I had a pizza box. And then Rich will talk about we'll do the demo, and Rich will talk about the future of IoT and disruption and innovation. Briefly. So we're giving away a book, a Kindle version of this book. This is the Oracle Cloud book that we've recently updated with over 100 pages. If you want to be entered into the drawing, just email hello@viscosityna.com and we'll get you entered into the drawing. I'll give you a secret. If you send us an email, we'll send you a free copy of the book. You can download it on Amazon. And it's always being updated. Oracle changes their cloud screens every couple of weeks, so we're keeping it updated.
If you want to get in this drawing,
yep.
And you put in a card in the bag that Jeff takes around, then we'll put you in the drawing. And if you're here when we pull your name, then you win. You have pretty good odds. There's two of them. Not everybody has a card. So hey, there you go. If you write your name, email on it, sure. You could take a card and write your email on it if you want to get in the drawing.
Oh, that's hello@viscositynorthamericana.com. Yeah, and I'll have another slide at the end. We'll just send you a code for a Kindle book, and then that'll just keep it updated. Use their reader. So a little bit about me. I'm from Austin, Texas. I'm an engineer and developer. Those are my Twitter handles. I got involved with Apex quite a few years ago. I really like it as a low-code platform before we really had a word for that. I'm co-author of that Oracle Cloud Solutions guys that we're giving away, and I'm a co-founder with Rich Niemiec of Viscosity North America. I'm also a private pilot, which is why this subject is very interesting to me. And I have a passion for the red grape. My wife and I have a very small vineyard in Argentina where we run Oracle and pick grapes and make some wine. And so Viscosity this year, we will have, by the end of the year, have given more than 100 presentations around the country and worldwide. We give presentations through Latin America, Australia, New Zealand, Europe. Rich has been to China. India. Yep. UK. So just, and we're only about 50 people at our company, so it's one of the things we really care about, and it's something that we do to try to give back. So at the core of Viscosity is a very robust data visualization, predictive, prescriptive analytics, application development practice. You can engage us for assessments, proof of concepts, training, full-blown projects, and managed services. We do pretty much the entire red stack and quite a bit of things outside of Oracle as well. Just a sampling of some of our clients. We believe in innovation, and innovation we think is necessary for businesses to survive, especially now. And we've also written over a dozen books on data, the cloud, and Oracle, including Rich has a book, the Oracle 12c Performance Tuning. It's the best-selling book in Oracle Press. Turn it over to Rich, and he's going to level set us with IoT.
So why do you need to innovate? Peter Drucker said it best: the enterprise that does not innovate ages and declines. And in a period of rapid change, such as the present, that decline will be fast. So I always like to say, take Lou Holtz. Lou Holtz always says, you want to win later? Remember, win. What's important now? I think what's important now is start to learn those pieces of what you can build. You're going to see one app you can build, but you can build anything your mind can think of. And that's the key to this. How many people are familiar with this Gartner hype cycle? This is like coming up this side here. It's like these are things coming on. These are things you're so sick they're talking about them forever. You want them to shut up about them. They're overhyped. And then it kind of goes down. Oh, I don't know if that's ever going to take off. Then bam, it takes off and people are actually using it. And how many years it takes to go through this hype cycle is based on the color of the thing. So something like quantum computer is going to take more than 10 years. So you could see in 2013, it was kind of all about tech, you know, big data, predictive analytics, the cloud to some degree. But if you look at innovation and how you're really going to make that impact, you know, innovation is something new. You look at companies today and Wall Street will back a company to wipe out a company that's been in business for 50 years. Why? Because the company that's been in business for 50 years doesn't innovate. They stay in the past. They don't leverage technology. They don't leverage big data. They don't leverage Internet of Things. They don't leverage robotics. And what happens is, let's say you invented the telegraph way back when. It's picking up, people start buying it. Now tons of people are buying it, and then all of a sudden nobody's buying it. Why? Because maybe the phone came out. Some new technology passes it up. So you always have to be able to say what's important now is to be able to realize what technology is gone. It's the telegraph. And what's the new technology? The telephone. And no matter how much money you put in, these old companies will put in all kinds of investment in an old product, and it doesn't lead to very little. We saw postal mail, all of a sudden there's a lot of email. Doesn't mean there isn't postal mail, it's still there. There's probably people that are saying, I told you email wouldn't be big. Look at postal mail, still doing great. A telegraph went to the telephone. I remember my son seeing a dictionary. He was leaving college and somebody had thrown one out and he's looking at it like it's an Egyptian artifact. And I'm like, what is it? He's like, it's a dictionary, an actual one. He's like, who would ever use one? And I'm like, well, it's not used, so I guess nobody. Now it's going faster. Email, going to Snapchat, Instagram. People send you a picture. You know, you don't know what it is, they don't care, right? Can you keep up? USB is now in the cloud. I remember my daughter saying, what are you carrying a USB for? And I'm like, well, so I can move the file from here to here. And she's like, why? You know, why would you ever do that? That's idiotic. And I'm like, well, it's Microsoft PowerPoint. And she's like, you got to move to another computer that has PowerPoint? They have to pay for it on that computer too? You're going to carry it somewhere else? You're going to carry it everywhere? How stupid is that? I thought you were smart. But it's starting to move to where maybe it's going to go to implants, robotics. First, it's being implanted in a robot, but pretty soon it'll be implanted in you. You know, the computer was on your desk, then it was in your pocket, and it's on your wrist. Next thing is going to go in your wrist. It's coming. Google, why are they so successful? Because they're big on innovation. Ideas come from everywhere. They realize it's not just the top guy who has the best ideas. Focus on data, not politics. Sorry. Innovation, not instant perfection. Creativity loves restraint. I don't know about that one. IoT, coming fast. You're looking at it right here. It's right on the desk. You could build anything. Jerry's going to show you how. IoT inside a manufacturing plant. Machines just talking to machines. They don't need to talk to a person. You see it in all kinds of devices in the consumer area, whether it's wearables, video, audio, in your home. This one, when the baby moves, the bottle starts to warm up. So when the baby cries, the bottle's already warm. This one is like a refrigerator tied to your bathroom scale. So it's like, you know, we're not going to unlock the refrigerator until you buy more of this stuff. There's a Tide button, IoT, right on your washing machine. You press it, you get Tide. You got a 4-year-old, you're going to get a lot of Tide. And they know that. So they give you a Doritos button now. Press the Doritos button. That's a little better. Or no, we'll just give you Alexa. Then the little kid can say, Alexa, send some Doritos. How much? A truckload. You know, it's coming. Tracking animals with IoT. They're tracking you with IoT. You know, here's a little sensor in your shopping cart. You know, here Rich went around, he bought some milk, circled the Oreo cookies multiple times, didn't buy any. Why? Because tech was, you know, distracted him. So think about disruptive type of innovation. How you could disrupt your own company with innovation that passes something else. Go after the low-level people first. Doesn't use a lot of what you have. Then start going after the higher ones. But leverage big data, IoT, robotics. Let's see one way how to do it with Jerry.
Thanks, Rich. So I just want to play, this is a video that went viral on YouTube, and it has a really well done visualization, just to give you an idea of what air traffic looks like.
Is there any sound?
There should be, yeah. So early morning, we have this whole train of airplanes coming from the U.S. right over to London. As it starts to get busier, you can see them be routed into holding patterns, that sort of thing. Look at these guys. Those are military planes, right? So the way they track this is all this data is collected, sent out by the aircraft. I'm sorry, these are the military planes, yeah. Sent out by these aircraft, and they visualize it in three-dimensional space. These are a lot of helicopters going out to the offshore drilling platforms out of in the North Atlantic. So anyway, so how does this work? So we use two systems. We use what's called the Atsb air traffic control system. And this is a ship-to-ship communication that's installed in aircraft, and it's actually mandated to take effect in even the smallest aircraft within the next year. And they've also released the same technology into satellites. So there was some dead spots over the Atlantic. But basically, ground station, ground radar can track planes. That used to be the only way to track planes. And now the planes, since they have very accurate GPSs and radios in them, they can transmit their locations to other planes and to ground stations. Ground stations can also track aircraft that don't have any signals and then relay that through the system. And we're listening to that signal here with the Raspberry Pi. Unfortunately, I can't get a signal through this room, but we did pre-record some data that we'll show you. So how do you assemble this yourself? It's not expensive, right? I mean, the Raspberry Pi is a $30 computer. We bought 2 radios, both 1090 megahertz and 978 megahertz, an 8 gig micro SD memory card, battery, and some miscellaneous cables, and you can put this whole solution together. At the time I did this a few years ago, you had to do this yourself with software-defined radios and that sort of thing. But now you can buy the completed kits for less than $100. And one of the easiest ways to get going is to simply download the image from Stratix. This has been packaged up, and they have single band for $94, dual band, and then they can just send you all the parts. You even get a nice case. And then go download the software, the current version, off of GitHub. And this guy named Chris Young gave it to us, so thanks for him. And then it capitalizes on a piece of software called Dump 1090 that was written by this guy, Salvador Sanfilippo, kind of an interesting guy. But basically, he takes the radio signals, which are digital, and streams that data out into a file that can be visualized, or what we'll do is actually capture the output of 1090 and push it up to a Oracle IoT node. And one of the tools that we use is called Netcat. It's been around forever, the TCP/IP Swiss Army knife. You can use Netcat just about on any kind of program. So if you've got a computer that is transmitting some kind of data, run Netcat on it, and you can see what's going across the wire. You can take that data and throw it up to an IoT device, and very easily, now that becomes another IoT device, even if the device wasn't written for it. Dump 1090 clearly wasn't written for IoT. It was written to do one thing, and that's to transmit your location, to tell you about where you are in the airplane. But we're going to use it to actually capture data and stream it. So another tool we use is Iot Cloud Service. This comes in many different flavors. It's almost a software as a service product. So if you look at their fleet management and some of their other application layers that they've built on top of IoT, we're using kind of a basic layer, which is the Oracle Event Hub, which is basically based on, it's a managed Kafka service. And I think we talked a little bit about the components. So to put this thing together, I used a Raspberry Pi 3. That's one of the newer versions. They've even got some smaller ones, but we put the heat sinks on this thing. Go ahead and install the antennas. You want to make sure that you match the antenna for the radio, because that's going to be, you want to get the best signal you can get. I've gotten on this one up to 70 miles away. So at this time I had put a little piece of paper to separate the two pieces, but the thing lights up. It comes to life. It's kind of cool. You don't see that a lot in just pure software. So I needed a case. So I took this pizza box and a battery and just taped everything down, and then ran the cables outside. Okay, kind of see how we did it there. And then I took it flying, and it worked. So that was the first iteration a few years ago. So what do we do next? That application was reporting data locally. I was visualizing on this application here called ForeFlight. You're welcome to come take a look at it. So it told me where I was and what other planes were around me. So that was great. But now I want to get the data off of this thing and stream it to the IoT cloud. So what I'm going to do is find the process and the port that dump 1090's running on, and then run netcat. In this case, there's a derivative called Kafka cat that will take the output of that port and push it to the Oracle Event Hub. If you don't want to use Oracle Event Hub, you can use Kafka, or a really nice derivative of Kafka called Confluent, which gives you some database features and allows you to store, virtually infinite data, so you can come back later and get to it. It also gives you a REST API to query that data and apply some schema to it, because otherwise it'd be pretty much schemaless. Basically what we do is Kafka Cat becomes the producer of data. It produces data on what we call a topic, and then that goes into Confluence or the Oracle Event Hub. And to get it into the Oracle database, we're using Oracle Database as a Service, which is another Oracle Cloud product. And it allows you to store both schema tables, as in the traditional sense of a relational database, but we can also store JSON or schema-less documents. And we use an adapter called Kafka Connect, and we push data to this database through JDBC. And then on top of all this, we built an application that basically is HTML5 and JavaScript, and we use the JavaScript Google Maps API to visualize the aircraft locations. Here's kind of what, if you do netcat on the data, this is kind of what the raw data looks like. It comes streaming out. I've gotten up to 300 rows a second from this thing. So it can stream quite a bit of data with very minute aircraft positions, or you can kind of chunk it down so it doesn't stream as much. But that's kind of the nature of things. Is as we switch from kind of a batch program to a streaming program, we're going to be ingesting all of these streams. And later we'll apply some schema types to them. So here's an image of kind of what the record types look like, what those fields mean. We have aircraft IDs, hexadecimal identifiers, altitude, latitude, longitude, any specific alerts or emergencies, and then there's even one that basically tells you if the aircraft's on the ground. This is just another vision of what you can do with Kafka. You've got these producers. You can stream data to multiple nodes on multiple availability zones, and you can consume it when you want to. So the first one, as we go into the demos, so since we're not getting any signal on this one, I'll just show you real quick what the producer and the consumer look like. So here's some data that I streamed. Let me zoom in here, sorry guys. Okay, that's a little bit better. I need my mouse back.
I don't see anything.
Oops. Okay, it didn't like that. Sorry. Now I wish I hadn't have done that.
I still have it on the US. Well, I don't have that though.
A spinning beach ball of death here. Looks like it's coming up.
You want to show them how to spin these? Does this play music?
It doesn't turn it on. Lights up.
These are actual. How do I turn it on?
You'll see the power button on the back side. Oh, there's the three buttons. You're showing the different motors.
Good God. Okay, I can see my screen here, so let me just gather these windows. And sorry about that.
Can you
Okay.
play a song? Oh,
About
do
to.
it.
All right, so I'll just
Because it was JC's down, down, down.
zoom in.
Go ahead.
Okay, so here we go.
We have a song for you.
Actually,
Go
don't
ahead.
play a song, Jeff. Don't do that.
The song that he has on there is down, 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 down.
Maybe you're in town.
Your answer would be yes, 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 yes.
Okay. Well, sorry? View menu, yeah, I don't want to mess with it anymore, but I'll zoom in here in a second. Okay, so. Well, anyways, I had done this previously, so here's what that data stream looks like. So these messages come from Kafka, and then what we can do, the Raspberry Pi will actually push those messages on there. And so this is what that looks like. So we've got, producer, and let me see if I can go in here.
Can the aircraft relay their neighboring planes' telemetry, or is that really?
So ADSB is also a mesh network, but only if you've got, there's two versions of it. There's ADSB in, and then there's ADSB out. Only really modern aircraft are equipped with ADSB out, but in 1 year they'll all be mandated to do that. So they do relay ship-to-ship information from the ground station, and the ground station is responsible for picking up weather as well. And the digital weather information is broadcast over something called Atsb, and that is also relayed from ship to ship.
So you make it way better than the 7
Yeah, you can see better, and at the end I'll show you a kind of a crowdsourced solution where you can collaborate with other people that do Raspberry Pi as well. So anyways, we got producers and consumers. That's what I was trying to show you about that. I apologize. Let's just stick to the slides and then the demo. So, and slideshow. And so basically we use this Kafka Avro console producer and consumer commands. And this is kind of what the database looks like and what a message sample looks like coming out of the Raspberry Pi.
For US?
Huh?
This is just for usage within the US?
United
So
States
some
only.
of the data like altitude or speed, I'm sure part of you know about the Kimberley glider.
Of a what?
The Kimberley glider, the airplane that ran out of fuel because Canada had introduced a metric system and the US still hasn't.
Oh, I gotcha.
Are these, metric units or
Well, those are, those are in feet, and that is universal in aviation. And the speed is given in nautical miles, and nautical miles are based on the circumference of the Earth. So, yep, that's a good
I
question.
think the US introduced a normal system and then you introduced the electric second, actually. But just, not that it's not better.
But
just
they don't call it a
second.
quarter pounder with cheese over there?
We better move on.
All right, so we're moving. So IoT Cloud, again, this allows you to do this in a graphical way versus the way I tried to show you. You can explore the streams and give the demo. So I just want to show you the application that we built. And so you can see this is written in Oracle Apex. Has anybody used Oracle Apex? Yep. All right. So Oracle
Very
Apex.
simple to use.
Extremely simple to use, yes. So low-code development platform. Let me see here, updated. And I want to run flight tracker. Okay, let me log in. All right, so I log in. I want to watch all of these. Okay. And so this is just the last data set. I've got the refresh set too high. Let me do.
So that's you if you were up in the air this afternoon.
So basically that's, I'm sorry, this thing's trying to, but basically, that's it, my plane's, okay, there we go. Okay, so it's not showing you the track and the orientation, and it's moving the aircraft. So this is some data that we recorded earlier. A little chunky, the data, because I had trouble seeing through some of the buildings, but that's kind of the idea. And the network is extremely slow. That's basically the demo. And if you want to see kind of the code, it's really simple. There's one page to this application. Or there's two pages, a login page and then this page. Sorry, the network's a little slow here. And if I go to the map region, we'll blow this up. And make this bigger. So basically you just set up initialize the map. All right. Create map. And this is a neat function here. This is plot all flight paths. And this is user-defined JavaScript function. And this plots a single flight path, and that's for if we only want to plot a single plane. And then this one plots all the flight paths. And this is just straight out of the textbook Google Maps API. Okay. Let me do this. Okay. And let me turn it back over. Where are we going next? Turn it back over to, oh yeah, any useful use cases. So I did look on the internet and I found there's a lot of people that have put their toaster in IoT. They've both done it as makers and they actually have productized this solution. But I was looking for some real world use cases. Of course, the obvious one is air traffic control. It's already in use, collision avoidance, for example. But you might use it to survey a competitor. Maybe Gordon Gekko is flying to, Erie, Pennsylvania to buy Anacott steel, and you want to know where he's going. That would be a really easy thing to do. You can crowdsource a worldwide tracking system if you get a bunch of these and get people to participate, and that's actually been done. So I'll show you how to tie into that later. Curiosity, maybe you live near an airport and you've always wondered where that plane's going. Maybe the Airbus A380, huge thing, right? It's just flying over. I was like, hey, where are they going? Fleet tracking, so where is my fleet? And I actually had an interesting use case from a cargo company. They wanted to know when the plane was on the ground because for some reason they didn't, it wasn't their planes, it was different planes, and they were always scheduled differently. So they want to know when that plane touched down so they could mobilize, and they had no way to do that reliably. This would be a $100 way to do that. Event correlation, the tax man here in California, I know you guys have a lot of taxes. Use tax, you have a very expensive airplane, $10 million. You might want to know when that airplane is using your county. And asset valuation. So used airplanes have different values based on usage. If a plane's just sitting there rusting, it's going to really affect its value. Still going? Okay, so crowdsource aircraft tracking. So FlightAware is, I don't know if you've used it, it tells you gate information, but also where planes are. It uses exactly this technology as part of its system. And if you connect the Raspberry Pi, if you build one of these and connect it, you actually get their enterprise $90 a month solution for free. So now you can have an API that you can interrogate that's worldwide, to your point earlier. and that's for free. So you can write API calls and build applications on top of FlightAware just because you've connected a single Raspberry Pi to their network. Let me turn it around to Rich. He's going to talk about where to take this in the future.
I don't know where you guys will take it in the future, to tell you the truth, but it's up to you. How many people ever watch Twilight Zone? You watch it today, I'm telling you, half of the Twilight Zones, they're already happened. Or you can see them in development. So right now is the time, but why? And this is the reason why. Why? Because when you look at something like 8-bit, that's 2 times 2 times 2 times 2, 8 times. It's 256. You know, back then when I was playing video games, you know, you get to screen 255 on Pac-Man, what happens? Screen splits, buffer overflow. It's too high. So then we got to 16-bit, and what happened? We got Windows. Because people could put more code that was addressable in memory. This is the amount of memory that's addressable for each of those. 32-bit, 4 gig. Now if you happen to put a sign, like use one of those 32 bits for a plus or a minus, instead of 4 gig, you only get 2 gig, just to let you know, which some people do. But 4 gig, what did we get when it hit kind of mainstream? 32-bit. Got the internet. I put it in miles per hour. If Windows was 1 mile an hour, the internet was 65,000 miles an hour, looking at it bit by bit. 64-bit, the jump we're making now, where you're starting to see more robotics, you're starting to see stuff like IoT. You're going to invent some, I'm sure. Give me and Jerry a few shares, don't forget about us. 300 trillion miles an hour. You're going to see robotics. I mean, it's going to be substantially different. And then after that, 64-bit to 128-bit, 5 trillion billion miles per hour. So you're going to see implants en masse. I mean, let's look at those numbers again. It's just the way it jumps. You know, God obviously wanted things to start going fast right now. So you've hit the right place at the right point in time. You're literally in the right place. Start leveraging this technology. 2015 wasn't all about tech anymore. All of a sudden it was all about robotics, human augmentation, you know, building your home to be connected. That's what became big. You know, you go to Honda, a robot takes you to your meeting, pour you a cup of coffee along the way. They don't have this yet, but I figured in the future, you know, you go to a company, they're probably going to have this Da Vinci surgical system. I don't know what it was, $10, $20 million only. They're going to be like, you know, on the way to the meeting, you want to get that appendix out? You know, you're showing some sensors, some pain there. We'll just pull that out on the way. We'll just carry you to your meeting. How about that? Available now. All of these things. They're already there. So what's the hype cycle in 2016? 2017 won't come out until 2018. But it's all about implants. You know, human augmentation. Taking prosthetics and starting to augment them so they could put them inside you. Taking computers at nanotechnology, putting it inside your bloodstream so you can wirelessly communicate with stuff. Larry Ellison invested in a company where you take the pill and it can tell you what you ate, tell you exactly what's in your stomach. It's there today. You know, so instead of Instagram, it's going to be just implant. You know, the picture's going to pop into your head, I guess. This device down here at the bottom, this is one Israeli company. It's in your bloodstream. You know, you spin that little dial based on your blood flowing, and it will power devices. You know, so if you're in the middle of the desert, you know, you can use that. Or you can use it here. I think I'll plug it in myself. They're already implanting into the brain. It's already happening now. Here's a mouse. They put some implants in, and it runs a more complex maze. Works today. Here's a lady, uses a robotic arm to get a drink. It's there today. Because of 128-bit and 256-bit, which is about a half a Google, if you know what a Google is, G-O-O-G-O-L, one with 100 zeros on it. With 256-bit, you're going to get about a half a Google. But they say that 2045, you know, there'll be that point where you will transcend biology. You know, if you cut off your arm, is it still you? If I get a prosthetic, is it still me? What do you think? Who says yes? Who says no? Okay, what if I get a new heart? People would get a heart transplant in the beginning. People were not sure it was going to be them when they woke up. What if they could 3D print with my own cells a kidney? They've already done it with mice. Is it still me? People are working on where they can print your face when you were 30 years old and burn off skin and print on a 30-year-old. Don't laugh, it's happening right now. They're working on it. So what happens when you can go into my brain and print everything that's in there? And I print a clone, and he knows everything in me. Obviously, we split at that point into two different things. Is it still me anymore? Who says it's still me now? Anyone? Because that's what's going to happen when you hit 2045. They're saying it will absolutely be possible. And we'll start to hit this where you're transcending biology. And they call it this singularity, if you've ever read Ray Kurzweil's stuff. It's the guy who invented the reader for blind people. It's one of his inventions. But it's that moment in technology where things go so fast that there's a rupture in literally human beings. They can't handle it anymore. And they say that point's going to happen in 2045. There's not many things that go on time that they say this is coming in the future that I haven't seen in my lifetime. Downside is security. Anyone see Ghost in the Shell? This used to be a cartoon. Anyone see the Japanese cartoon Ghost in the Shell? Came out in the 80s. It's very good, just to let you know. But it's about hackers that will hack into your mind, you know, and how to prevent that. You know, right now they're just hacking into Equifax. Well, as you build implants, somebody's going to figure out how to do that. I like this one. I tweeted this a little while ago. But it's like, you know, hackers. $30 in Bitcoin, or the next time I smell smoke, I just might let you sleep. Oops, sorry. You know, this is the internet of ransomware things. Your Roomba is like, you know, wire my hacker some money or I'm going to blow dirt all over this place. How long will it be till that happens? Till they lock your refrigerator, till they lock you out of your car. It's starting to happen. How do you be competitive in the future? And the answer is integrate technology. You know, how are you going to beat robots and AI? And the answer is you're going to be the guy implanting things to compete with that robot. Cyberdyne Systems, oh, that's an interesting name, built a HAL suit that makes you much stronger. If you can't walk, you're able to walk. You've seen, obviously, Apple Watch, virtual reality. But the goal is going to be to start implanting things in you so that you can compete with those robotics. Final thoughts. Anyone remember Star Trek? Didn't it look futuristic way back when? I mean, look at that phone they're using. What if you put out a phone today that looked like this? People would laugh you out of the business. What is that ancient thing? Where'd you get that? Ancient Egypt? Things are accelerating tremendously. Ghost in the Shell. Those who use things of the world, it's passing away. Ghost in the Shell is about even networking different minds together. You know, you're kind of networked in this room right now, but they're going to physically do it in the future. Some people think, you know, oh, that's impossible. I always say nothing's impossible. When I came here 20 years ago, I had to go to a company event. It was raining. I thought it's impossible to get a cab. This is before the days of Uber and all that. And right then a cab went by and I was like, taxi! And it just kept going. I was like, taxi! Can't believe it. One went by and he won't stop. There was a red light, so I ran up there and I looked in the window. I'm like, taxi! And he's like, all right. He goes, where are you going? And I told him. He goes, all right, I'll take you. I was like, sorry to put him out. I mean, maybe he was off duty. I don't know. So then he takes me there, and I'm like, how much is it? And he's like, notice there's no meter. And I'm like, wow, there's no meter. Why is that? And he goes, because I'm a pizza delivery guy. And it looked like a cab because they had like the thing on it. And I said, well, why did you take me? He said, you were just so insistent. And so how are you going to create the future? You have to believe you can do those impossible things. And I'll leave it for Jerry to close for us.
That's it. Well, that's it. I hope we covered kind of what you were looking for. Again, let me close with this quote. Things may come to those who wait, but only things left by those who hustle. Abraham Lincoln. Again, hello@viscosityna.com if you want the book.
One of my two winners are,
Okay.
three, I mean. That's what I said.
Julio Machicado.
Julio, you are the first winner. You get your first pick, one of those three.
Peter Erickson, Air Traffic Control System.
Is he here? Well, I'll see if he's here. He's got to be here.
That's him.
Oh, okay.
MIT guy.
You know him.
And Richard
This one or
Scope.
this one? This one's already got a song on it. It includes a chip.
This one's gold.
Take whatever you want. It's all yours.
This one's got a.
That one's ready to go. And everyone else won candy, so you can come and get some candy.
No worries.
So thanks for coming. Have a great day.